Okay, we're beginning section 2.2. We've completed section 2.1, and that was a labor-intensive section. And now we're going to ease up a little bit and go from converting a linear system to a matrix form. And the title of this one says Solution of Linear Systems by the Gauss-Jordan Method. We'll be relying on our calculators, but some of this we'll do by hand just to get familiar with the processes. Now, we understand that if we had a linear system, we always converted it into the form of some ax plus by equals c, or with the variable z as well. Then the linear system is converted to a matrix with only the coefficients and not the variables showing, and it's called augmented because we have the solutions listed on the far right column. There's going to be 0 placeholders for any variable not listed, and that would be a first step in understanding how a matrix will work. All right, then we have these steps here. This is from the textbook, and it's how to perform it. And it's the same process we did with the system of equations, only without the variables showing. Much easier and less likely to make a math error like your instructor did when she was doing the 3 variables. So let's look at what we have. And we're first going to start with how to construct a matrix. First off, we know that this is a 2-row by 3 column. All right, row 1, row 2, and this is column 1, column 2, and column 3. So what we're talking about is constructing an open bracket, and we're going to put only the coefficients. The coefficient to x is a -4. The coefficient to y is a 3. And augmented means we have a line to separate the outcome. The outcome was a 2. The x is an 8. The y is that's a y. Sorry about the typo. 5. And the outcome is 1. So this is row 1, row 2 to stand for the system of equation listing. This is my x column and my y column, and this is my constant column, which is the output of what we had. Definitely easy. Here we have a 3 rows by 4 columns. I'm going to put a capital C. All right. So we're going to go with our 3 rows and say 9 for x, -3 for y, and our z is 6, and our augmented is -1. Then here I'm going to have an 8, a -8, a 5, and a 9. Here I'm going to have a 0 for x. Then I'm going to have an 8 for y, a -2 for z, and a -1. This is my augmented matrix. All right. So how do we read solutions? All right. So to understand that, we have to understand an identity matrix. And the matrix is 1, 0, 0, 1, and then our solutions are here. And this is some x value and y value. Now, if we have 3 columns, well, then we would have x, y, and z. And notice that we have only a 1 on the x column, only a 1 for the y column. So if we're reading this, we know that this is augmented. So x equals 4 and y equals 1. All right. the system of equation associated with a given augmented matrix is. Now they want us to expand to what the system of equations look like. But they're all solutions. So in this case, we have an X column, a Y column, and a Z column. So X is equal to 10, Y is equal to 9, and Z is equal to 2. And of course, using the variables implies that you know how to read the matrix. Well, now let's change it. So they're saying use the indicated row change for the matrix. Replace row 2. This is this one here. We're going to change this guy by, and here we go is our format. And we're going to say row 2 plus 8 times row 1. Okay, so I'm going to put my row 2, and then I'm going to have my row 1 by 8. So 1 times 8 is 8, negative 8, sorry. And then I'm going to have a negative 64, as I'm multiplying this row by negative 8, a negative 64, and a positive 64. And I'm going to add them. And this zeroes out. So I'm going to have a negative 72, a negative 68, and a positive 60. So this is my new row 2. So I have my original. Now I have a 0, negative 72, negative 68, and 60. And the third one we haven't done anything to yet. Sorry. So this is the new row 2. All right. This one says perform the 2 row operations, 1/7 row 1, and replace row 1 on the following matrix. So we have 1/7 times that row. So I'm going to have a 1, 0, 0, 2. Everything else is the same. And we're getting ready to do that solving of that system. All right. Use Gauss-Jordan method to solve the following system of equation. All right. So we first convert to a matrix. Right. So I'm going to have a 4, a negative 9, and a 7. I'm going to have an 8, a negative 18, and a 1. Right. So if we're doing this by this method, we would then take our time and say, okay, what do I want to get rid of? Well, I got to get rid of that 8, right? So let's do that. Oops, sorry. Here we go. So we're going to say the new row 2 changes by row 2 minus 2 row 1s. All right. So I'm going to have this guy with a negative 2. All right, so that'll give me a -8, a +18, and a -14. I'm going to have an 8, a -18, and a 1. So if I add these together, this goes away. Well, unfortunately, this goes away. So I have 0 equal 0 and -13. Well, we know this is not true. So we can't go any further. So it is uh, inconsistent. No solution. All right. So let's see what the next one is. The next one says use the Gauss-Jordan method, and we can see what we have. We have x and y's, so we're going to convert to a matrix. All right. So I have an 8, a -5, and a 7. A 24, a -15, and a 21. All right. So we can say for row 2, changes by row 2 minus 3 row 1s. All right. So I'm going to multiply 8, -5, and 7 by a -3. Okay, so this gives me a -24, a +15, and a -21. And I'm going to add row 2 to it, 24, -15, and 21. So when I do that, I get zeros, right? Zeros all the way across. So I now have 8, -5, and 7. And I have zeros all the way across. So if I have zeros all the way across, then, or do I have, let's see what I have. What did I do here? 21, and this one is 21. So I have all solutions, because this is true. All solutions, because there are zeros all across. And when you do that, well, then you get all solution. Is everybody comfortable with that? That means you can make X be anything or Y be anything. And then you can state, because we said this, and it is dependent, we now take any one of them. So we can say 8x minus 5y equals 7. We're gonna solve for x. 8x equals 5y plus 7. I'm going to divide by 8 so that x is defined as 5/8 y plus 7/8. So whatever we decide y to be, x will be that value. And for all solutions. Is everybody comfortable with that? All right. Now we have this one here. Now first we have to change it to proper form. All right, so I have to move the x over. Plus y equals -6. I'm going to move the z over. Okay, I have to make room. So I'm going to move the z over. I have y minus z equals 2. And the last one is x plus z equals 2. All right, so this is my system of equations. Now we're going to make a matrix. -1, 1, 0, and -6. Row 1, -1, and 2. 1, 0, 1, and 2. All right. And now they want us to use Gauss-Jordan to solve it. All right. So I've got it listed correctly. So now we're going to solve it. Let's see. What do we want? We want row 3 changes to that. Row 3 plus row 1. So I've got row 3, 1, 0, 1, 2, and I'm adding to it row 1, 1, 0, and 2. I'm sorry, -6. Sorry about that. So that's going to zero out. I've got 1, 1, -4. All right. So now I have, and I'm going to divide by -1 on this guy. So I'm going to have 1, -1, 0, and 6. Row 1, -1, and 2. 0, 1, 1, and -4. All right. So in this case, I'm going to have the use of our calculator now. We're going to use our calculator. Or we can work it out, one or the other. Let's work it out by hand first. So now what I'm going to do is row 1 changes to row 1 plus row 2. Okay, so I have 1, -1, 0, and 6. And I'm going to add the second row, 0, 1, -1, and 2. And this guy becomes 0, 0, I'm sorry, 1, 0, -1, and 8. This is the new row 1. All right, so let's look at that. We're going to do it by calculator because you can see all this little math and drive you nuts. 1, 0, -1, and 8. 0, 1, -1, and 2. And 0, 1, 1, and -4. Okay. So now I have that matrix. So I have the 1, 1. I need to get rid of this one. So row 3 changes to row 3 minus row 2. Okay, so row 3 is 0, 1, 1, -4. And I'm going to subtract that one. 0, -1, 1, and -2. All right, this zeroes out. So I have 0, 0, 2, -6. So now I'm going to divide this by 2. That's 0, 0, 1, -3. All right. So now we have a solution. We have this as a solution, and we can go backwards and figure out the rest. Or we can do it one more time. Because once we get to this guy, then everything else will work out. But if we wanted to do it anyway, we can say 4, because that's how Gauss Jordan works. Z equals -3. So if I have y minus a -3 equal to 2, well then y plus 3 equals 2. Then I subtract it, then y equals -1. And so now we have what y is. Because once we have one solution, we can go to the rest. So then we have x minus a -3 equals 8. X plus 3 equals 8. X is 5. So we have all three solutions of 5, -1, and -3. Now I'm gonna instruct on using your calculator. Is everybody comfortable with that? That's a good solution right there. But I made you buy a TI 84 CE so that you would get answers quickly. So we've got 5, -1, and 3. Oh, -3. Sorry about that. -3. Okay. So now we're going to talk about our calculator. On the TI calculator, let me clear everything. And let me make it a little bit smaller so you can see it. Hold on. I opened up stuff, and I'm sorry about that. That happens when I'm working on this thing. Very sensitive. Okay, so let me check my calculator. Boom, you can see it. All right. So we're going to first understand how to enter matrix. All right. So that means we go to the second key, which is the first, it's a blue key. First row, first key. And then we're going to hit our matrix, which is the opposite of the inverse. It says matrix. Because if you hit the second, you're talking about the top part. So in this case, let me see if I can get it. I don't have a blue highlighter, but I'm going to use the second key and that. But understand it's a blue key. All right. So this will open up matrix window. Second matrix. So okay, there it is. This is a window. Okay. So this is the window, matrix window. We want to edit. Arrow over to edit. Okay. That means you arrow over and go over to get edit. When you get to edit, watch, okay, you get it highlights one and enter. So we hit enter. All right, once we hit enter, again, you'll see this guy. And on the flashing cursor, you enter row first by column second. So what we're entering, if you remember when we first started this, it was a 1, 2, 3 rows by 1, 2, 3, 4. Okay, the 3 by 4. So I'm going to enter my 3, side arrow 4, and enter. Okay. Now enter each value of rows followed by enter. Right. So, okay, now remember my matrix, the original matrix that we had right here. This is our matrix. So I'm going to enter, and remember, negative is that bottom key to the left of enter, -1, enter, 1, enter, 0, enter, 6, enter. Okay. Now go back. I got to go back. It's -6, and I forgot the negative. It would have come out of negative, that wrong answer. -6, enter. Now I'm in the second row. 0, 1, -1, oops, -1, and 2, enter. I'm on third row. 1, 0, 1, and 2. Okay. Then you check to make sure that all of your numbers are correct, and you're fine. Okay. Make room. So this is when the data is entered. And you check visual. Now you want to get on the home screen. So you do second quit, second mode. That's quit, whatever program you're in. Second quit for the home screen. All right, so I'm going to do second quit, and I'm right there in the home screen. I'm going to give it a command. All right, so I'm going to go second matrix, arrow over to math, and choose RREF. So you're looking for this guy right here. It is B, okay? And you choose it and enter. When you enter, it'll paste it on the home screen. All right, now you have to name it. Second matrix name and hit enter. And now you have it with the command. It has to have a matrix to work from. And the last step is enter to say work it. And there it is. And this is the solution matrix. It's possible. So here we have x equals 5, y equals -1, and z equals -3, which is what we did by hand. All right. Now you have to practice to make it work. It's not going to work if you don't practice doing it, and it does become easier as you do it. Now I'm going to close on this, and from this point on, I'm going to be using the calculator. And you can see that we had that answer up here. Let me see, where did I write it? There it is. There's our answer. 5, -1, -3. 5, -1, -3. So lots easier. Just be careful. You have to, on your notes, you have to write the matrix so you know what to enter and what size it is. And so I thank you for listening so hard on this program. And this is where you're paid off for buying that calculator. Now, remember, I told you that when we started the course, it was a needed necessity, but you can download it on your cell phone as a TI-84 simulator and do just fine. It'll cost you like under $6, over 5, under 6. So if you can't afford the 100 plus for the calculator, then by all means get it on your smartphone. Thank you for listening.